The present solar theory depends on the belief that matter and gravity are inextricably bound together, that one always determines the amount of the other. However, if nature allows for gravity to be created with less mass, then observations that have been at odds with present models start to fall into place. But how can you have more gravity with less mass? That's what this video is all about. Our concept of the gravity and mass relationship is so ingrained in the sciences of our contemporary civilization that it's become the natural starting point for any endeavor in astronomy and cosmology, with very little scope for alternatives. Indeed, faith in this belief structure is not without good cause. Every experiment with solids, liquids, and gas in any combination gives us every confirmation that this is the nature of things, that any theoretical consideration of solar interior should rest on a foundation in the belief that matter and gravity are synonymous with one another, that the relationship between substance and resulting force are an inviolate bond, that if you have X amount of mass, you must have X amount of gravity. And so, the gravity-mass relationship is at the root of any standard solar hydrogen fusion core modeling. A large body of mass is gravitationally pulled into a ball. The amount of matter is so great that the gravitational pressures allow for fusion reactions to occur in the central core, and the radiation from this energy source is released, working its way outwards until it reaches the photosphere, where it issues forth to produce light and radiation that we observe. This is essentially the solar model that has been standard since the 1950s. But all is not well. Ever since the inception of the core model, a gradual store of observations have accrued that decidedly do not conform to this model. Taken individually, these disparate sets of data can be rationalized, set aside as curious anomalies, observations that are eventually expected to be explained and incorporated into the solar hydrogen fusion core model at some future date. But when taken as a sum, these seemingly small contradictory observations build a picture completely at odds with the present solar model, so much so as to make it untenable. So let us briefly examine these observations. It's hard to appreciate the scale of disparity between the parts that make up the hydrogen fusion core sun. At its core, the temperature is supposed to be 15 million degrees Celsius. The photosphere surface has a temperature of a mere 5,500 degrees. The corona, often described as the sun's atmosphere, varies between 1 and 10 million degrees Celsius. This is what the scientists refer to as the coronal heating problem. Magnitudes such as these can be hard to appreciate, so here is a model that can help one grasp the problem. Let us pretend we can drop the temperature of the photosphere to 0 degrees Celsius, so this shell is the temperature of the snowball. Then let us drop the temperatures of the inner core and outer atmospheric corona in proportion. So, sandwiched between our snowball shell, the core would be 2,700 degrees Celsius, hot enough to melt steel, and the atmospheric corona would have a temperature that varies between 180 degrees to 1,800 degrees Celsius, a temperature so hot that if you were standing in the vicinity, you would either parboil or vaporize. Your choice. exceedingly high temperatures, with a snowball shell sandwiched in between. According to the laws of thermodynamics, that's one hell of a problem. You can't pass heat from a hot core through a cool photosphere and then have it heat up again once it reaches the corona. Can't be done. It might have been easy for the hydrogen fusion core proponents to scale the energy output density to conveniently fit the temperature of the photospheric shell, but when the temperature of the corona was discovered to the magnitudes higher, suddenly no adjustment of the never-seen interior of the Sun made any sense at all. So, based on this observation, the contemporary core theory is a bust. One of the earliest and most impressive observations that can be made of the Sun are sunspots, dark blemishes that appear on the photosphere from time to time. These usually come in pairs. They're depressions in the photosphere and let us see a little further into the Sun. Issuing from these, immensely powerful magnetic fields blast outwards and link to their neighboring opposite polarity sunspot twin. And at the same time, sunspots are associated with various plasma configurations we can observe directly above the photosphere. Seen through the filter of the hydrogen fusion core theory, this darkening of sunspots begs explanation for obvious reasons. With a hypothetical solar core temperature of 15 million degrees Celsius, shouldn't such holes, revealing a peak further into the Sun, not give us sunspot lights rather than the dark sunspots we observe? And so a convoluted justification is necessary for the darkening of sunspots in the photosphere, the proposition that magnetic fields are somehow the cause of sunspot darkening. However, two glaringly obvious contradictions stand out in stark relief. First, after the magnetic fields punch through the photosphere, creating cooler sunspots, these same fields then rise into the solar atmosphere, where they magically cause the temperature to rise magnitudes higher than the origins of the sunspot. Did the magnetic fields somehow change? To confound the problem, this is a case of hot to cold to hot, and does not sit well with the laws of thermodynamics. A hot core, then cold holes through which magnetic fields emanate, proceeding to interact in the solar atmosphere at temperatures which are magnitudes hotter than they were at the sunspot level. And so, convoluted, hand-waving explanations are necessary for the hydrogen fusion core theory to be viable, and frankly, these stretch credibility. Secondly, the hydrogen fusion core theory then has to go on to explain the darkening in the actual sunspot depression, when it is obvious to the casual observer that the core of 15 million degrees ought to exhibit a bright interior, not darker. Based purely on observation, and setting aside our preconceived notions of a solar interior, sunspots offer us a plain explanation that however much contemporary theory desires the opposite, there is no evidence for a hydrogen fusion core. Put simply, observation would suggest that it is not there. Then there's the curious observation that the Sun is as close to perfectly round as our instruments can measure. That's interesting because the Sun rotates, and according to calculations that were made before the discovery, the rotation ought to create a bulge at the Sun's equator. Because the Sun gives the appearance of a specific amount of mass, scientists put a considerable amount of effort into discovering how big or small the equatorial bulge might be, because it would give tantalizing clues as to the structure of the hypothesized interior mass. Now, if the Sun has X amount of mass, then by virtue of its rotation, it must express an equatorial bulge. And that's why there was so much speculation as to the size of the bulge. The astonishing discovery of a perfectly round sun seems to have passed without little or no further comment in the science community. But not by me. Why is there no bulge? There's no doubt that magnetic braking exists, but does it apply to stellar evolution? Despite sitting slap dab in the center of our solar system, the Sun has a remarkably slow rotation rate, about once every 30 days. Compare that to the outer gaseous planets rotating in a brisk 24 hours or less. According to the presently accepted accretion scenario, our early solar system came together by gravitationally contracting. If this is the case, our primordial Sun ought to have a rotation rate far greater than that of the planets. Think of a spinning skater on ice pulling in their arms and spinning faster. Consequently, our Sun's exceptionally slow rotation is completely at odds with the laws of angular momentum. This obvious inconsistency has not escaped the notice of stellar physicists who, in order to give some kind of rationale for this observation, have inadvertently hammered a round peg into a square hole by coming up with an explanation referred to as stellar magnetic braking. The story goes that the Sun inaugurated nuclear fusion at its core, simultaneously creating its external magnetic field. Because the field slammed into the leftover matter that was blown out and away from the Sun's radiation, this is supposed to have acted as a brake, causing the Sun to lose a large proportion of its angular momentum, slowing down its rotation. It seems like a reasonable argument at a glance, but fails to explain how planets like rapidly rotating Jupiter, with its strong magnetic field and large orbiting moons, appears to be completely unaffected by magnetic braking. Considering the 5 billion years that have passed since the creation of our solar system, one would surely expect that the Jovian moons would have slowed down Jupiter's angular momentum considerably, possibly to a point where Jupiter may have ground to a halt. This obviously is not the case, so where's the evidence for magnetic braking? Okay, Jupiter is not the Sun, so let's look to the stars. If stellar magnetic braking wasn't evidence, would one not expect to observe at least some of these stars, especially the older ones, to have ground to a halt? The death knell of the stellar magnetic braking theory comes to us via complements of the Kepler Space Telescope, which has been gathering data on thousands of rotating stars. Not a single star is standing still. No star has completely lost its angular momentum due to magnetic braking. They are all rotating. Even if we were to discard the accretion theory and adopt the contention that stars come about from gas nebulae plasma flux filaments, I would strongly suggest that within this framework, the laws of angular momentum still would apply. So, stripping away the fanciful stellar magnetic braking theory, this leaves us with the oh-so-slowly rotating Sun without a viable explanation. So, why does the Sun rotate so slowly? In the 1960s, it was discovered that the Sun vibrates, rather like a bell. Solar oscillations came as a complete surprise to hydrogen fusion core theorists, because one doesn't associate structure that gets denser towards the center as an effective oscillator. Nonetheless, by the mid-1970s, the discipline was effectively slaved to the name Helioseismology, inferring that the vibrations come from deep within the solar interior, a concept that hydrogen fusion core theorists were entirely comfortable with. Sadly, the term helioseismology serves as a mindset, a distraction from its true scientific purpose, which is to study the solar oscillations without any preconceived bias. Consequently, all effort of discerning the nature of solar oscillations was turned inwards, wedding the discipline to the groupthink of solar hydrogen fusion core concept, the notion that the oscillations originated from deep within the sun. And this new tool would allow scientists to study the deep interior. This is where helioseismology stands today, a tool linked to an assumption that has no basis of fact in the physical world. So, what was I listening to? The speakers or a musician? The same can be said for helioseismology. How can you know if applying the science to the hydrogen fusion core theory is the right course of action when you've never considered any alternative model? I realize it is hard to set aside the present conviction, an automatic assumption that solar mass must be present and wedded to the gravity we measure. The concept is so ingrained into our contemporary thought that it tends to exclude any other possibility. But just for a moment, suspend your belief and ask, when it comes to successfully oscillating, how does a solid ball compare to a shell?
All right, go for it.
3, 2, 1.
Based on the data gathered from the oscillating sun, I would suggest that the assumptions that have been made can be, and ought to be, challenged. Item by item, I've illustrated the various disparities that are completely at odds with the contemporary accepted solar model. 1. The coronal heating problem. The hydrogen fusion core model violates the second law of thermodynamics. How can you have a hot core, a cool photospheric surface, and a hot coronal atmosphere? 2. Sunspot depressions revealing a darker, cooler interior. How does one square that with a superhot core? 3. No equatorial bulge. Calculations maintain that the mass of the sun ought to manifest an equatorial bulge. Where is it? 4. The sun lacks angular momentum. Being in the center of the solar system, why is our sun not spinning much faster? 5. The ease with which the sun resonates. How can the sun possibly produce such amazingly coherent resonance considering the turbulence of a theorized inner core? Although solar gravitational attraction is undeniably present, observations of how it presents itself simply do not concur with the present gravity-mass equivalency model. That there is something fundamentally lacking in our understanding upon which this aspect of our science has been erected. So let us put the hydrogen fusion core theory aside and build a sun from scratch, just by using the observational data that's available. What would we be looking at? What does the coronal heating problem tell us? We're looking at a high temperature corona and a photosphere that is magnitudes cooler. Would it not make sense that whatever is going on below the photosphere shell ought to be cooler still? As an observational confirmation to the previous statement, Sunspots, these cooler, darker depressions in the photosphere, offer an even more blatant hint that the interior is a further drop in temperature. And this would be in accordance with the laws of thermodynamics, a temperature gradient going all in the same direction, from cooler to hotter. So let us assume that, however extraordinary it might seem, what lies below the photosphere is precisely what observation presents, a darker, cooler interior. If our rotating sun contains the mass our contemporary science ascribes to it, there must be an equatorial bulge. It's not there. So, setting aside the sun's gravitational attraction for a moment, the simplest and most straightforward way to explain the lack of equatorial bulge is to embrace the seemingly impossible, that the perceived mass of the sun simply isn't present. So, following the tenets of observational evidence, let us remove the mass from inside the sun, leaving only the photospheric shell. Am I enjoying this? Considering the velocity with which the outer planets rotate, the sun would appear to lack angular momentum. It doesn't spin fast enough. When a spinning skater puts out their arms, they slow down. Let's go with that in the simplest way possible and assume that the sun expanded into a shell, preserving the laws of angular momentum. And last, the ease with which the sun resonates. So, let the sun resonate in the most obvious and unhindered way. Again, we'll assume the total sum of the sun's mass is a photospheric shell. In summary, if we take the observational evidence at face value, what we are left with is a hot coronal atmosphere above a cooler photospheric shell beneath which there's a volume containing no mass. The assemblage just described fits the sun in every way, but I suspect demands explanation. If the sun is a shell, where is the mass that is supposed to make up the sun's gravity? Our contemporary mindset understandably considers the relationship between mass and gravity inviolate. That if you have X amount of mass, you have X amount of gravity. And from countless experiments, we know this is true so far as any combination of gas, liquids, and solids are concerned. But we do not know if this is true for plasma, the fourth state of matter. Our sun is a photospheric shell sitting on a magnetic bottle. The magnetic bottle sustains and contains subspace. I use the word subspace because it's a simpler and more descriptive word than to describe this phenomenon as an absolute vacuum. Subspace is a rip, a tear, a rent in the fabric of space, which the sun maintains by way of a repulsing electromagnetic plasma configuration. Subspace contains no space, no time, no temperature, no mass or energy, no forces that we equate with conventional space. How does this come about? Let us assume that any protosun starts with a gravitational electrostatic accretion of matter. Over time, the matter falls in towards an ever-growing, faster-spinning protosun. Eventually, the protosun core obtains sufficient mass that there is enough pressure to inaugurate nuclear fusion. The fusion event takes place in a sea of superhot matter, a plasma, which is an unified state due to the dynamo effect, and it is here that we branch away from the standard hydrogen fusion core model. The rapidly hot, rotating protosun sets up a plasma dynamo effect, which organizes the dissociated electrically charged electrons and protons into two polarized camps, a negative north and a positive south. This violently opposing magnetic polarization creates a rapidly swelling magnetic bottle, forcing the plasma before it as an expanding shell. The inside of the shell is a cavity, a creation of subspace. Like a spinning ice skater, extending her arms and reducing her spin, the expanding sun's rotation is reduced in accordance with the laws of angular momentum. The rapidly expanding subspace beneath the photospheric shell causes conventional space to implode upon the expanding protosun. The implosion of space upon the subspace cavity is indistinguishable from the force of gravity. The event is a gravitational induction, gravity without a corresponding quantity of mass. The subspace cavity is held in equilibrium by the outward pressure of the plasma-induced magnetic subspace bottle and the inward pressure of the space implosion. It is an energy cycle. The corona and photospheric shell are caught between the forces of explosion and implosion. Under this immense pressure, energy is released from the trapped corona and photospheric shell, which in turn maintains the plasma, which maintains the magnetic bottle, allowing for the maintenance of subspace gravity, which resists the implosion of space, which induces gravity. It is a perpetual tug of war and gives rise to the oscillations that we observe on the sun's photosphere. This removes the illusion of an interior solar mass that we have hitherto held so dear. It is an induced gravitational force that perfectly mimics the sun's attraction. I think at this point it would make sense to describe and illustrate what subspace is and what it isn't. This is a crude description of space. All space in the universe contains matter and radiation. There are no exceptions. However rarefied, all space is a potential expression of pressure. Attempting to empty rarefied pressure produces temporary virtual particles, ghosts that come into existence and then disappear. Hollow is defined as a space with nothing in it, except, of course, space. Empty is a more descriptive word for subspace, in that it can describe a volume with no space in it. A volume of subspace contains no time, no temperature, no radiation, no matter, no virtual particles. Subspace cavities cannot be directly observed. It is only by virtue of the gravitational implosion of space and the consequent energy that is emitted that allow us to determine the existence of subspace. This implosion has a violence equal to the initial creation of subspace. So we're talking E equals mc squared annihilation events here. And that's a pretty good description of our sun. Now, maintaining that gravity-inducing subspace exists could easily be dismissed as wild speculation, the feverish imaginings of an overactive mind. For this reason, I have devised a rudimentary sketch of a laboratory experiment that contests presently accepted electromagnetic gravitational dogma. A search through years of scientific journals and the web in general suggests that no attempt to date has been made to discern if gravitational induction is present at the moment of electrical discharge. I suspect there are two reasons for this. The first reason is due to the assumptions made of the behavior of electromagnetism by Hans Christian Ørsted in 1824, the basic tenets of which have not been revised or revisited in a contemporary setting. Ørsted and his successors simply did not have the tools sensitive enough to discern any weak interaction between the electromagnetic and gravity. The second reason is simply that it has not occurred to anyone to pursue this avenue because of the presumption of present electromagnetic dogma, which has been reinforced by almost 200 years of assumption. Fortunately, with the contemporary tools now available, it is possible to determine photon trajectory, and so this is fertile ground for laboratory experimentation. With the advent of a new generation of lasers that have the precision capacity of 1 × 10⁻⁻15 centimeters, and the now available highly sensitive interferometers, the experiment has more than a good chance of yielding a result that can determine one way or another if subspace exists. According to present theory, photons are not responsive to electromagnetic fields. Only gravity can alter the path of an unobstructed photon. Consequently, a laser beam of photons passing an electrical discharge and arriving at an interferometer is expected to denote no deviation caused by the discharge. This is an untested assumption. I propose that the interplay of electrons and protons in a magnetically organized plasma, such as one sees in lightning, produce momentary filaments of subspace. At the moment of their existence, these subspace filaments induce gravity without a corresponding quantity of mass. The rapid contraction and accompanying thunderclap at the collapse of a lightning discharge is, at its root, an induced gravitational event. So in our experiment, as the photons from the laser beam pass an artificially powerful induced electrical discharge, such as a Z-pinch, the photon path will be slightly diverted by the momentarily gravitational induction caused by subspace, and their arrival at the interferometer target will denote this. When one discounts the gravitational presence of the electron-proton mass that makes up the actual plasma discharge, there will be a further photon deviation that this mass cannot be accounted for, leaving little doubt that there is a gravitationally induced deviation of the photon. The experiment is repeatable and will confirm the observation. I would briefly like to point out some additional supportive observations that point to a subspace cavity sun. Could the sun propagate a magnetic field powerful enough to maintain a subspace bottle such as I have described? Solar loops are powerful magnetic fields that burst through the cool photospheric sunspots and reach high into the sun's corona, and then proceed to create towering organized plasma loops that can reach temperatures in the millions of degrees. These looped magnetic plasma structures contain a significant amount of mass. Nevertheless, these magnetic loops sit happily suspended above the sun, seemingly unaware of the sun's gravitational pull, as if it were of no consequence. How do coronal loops do this? These loops are highly organized electromagnetic phenomena in which dissociated electrons and protons organize themselves into like camps, each particle contributing its magnetic potential to the whole. A loop plasma configuration could hypothetically have a magnetic potential with a magnitude only slightly less than 1 × 10⁻39 times greater than the gravitational force. In scientific terminology, they are powerful juju. Though faced with the sun's gravitational pull, a force 28 times more powerful than that of Earth's, their structures show no sign whatsoever of being imposed upon by the sun's powerful gravitational attraction. Solar coronal loops are a pretty blatant hint that the sun's subterranean magnetic field is a force to be reckoned with, and it is sobering to consider that the loops are merely fading, temporary visitors below the solar shell, a pallid show of force compared to what must be magnitude-stronger magnetic fields that lurk beneath the sun's photosphere. Fields certainly strong enough to maintain a subspace magnetic bottle. The next natural phenomenon I'd like to present is that of sonoluminescence, which is the emission of short bursts of light from imploding cavity bubbles in a liquid when excited by sound. Experiments indicate that these cavity bubbles can reach temperatures above 19,000 degrees Celsius. Note that these cavity bubbles are not the result of any central object of mass suspended in liquid, but are instead the result of resonance, oscillations that one might compare to the solar photospheric shell. Another point of interest: when a gun is fired underwater, the bullet produces an extremely low pressure cavity. What is so impressive about these cavities is that they exhibit a surprising capacity for conserving energy in an organized manner, in that instead of the force of the cavity merely dissipating in the water, they oscillate, contracting, and then exploding outwards again. These cavities can do this several times before the energy is expended. I believe this to be a rudimentary action, a lower energy version of the two forces that continuously battle for dominance in solar propagation, a continual magnetic expulsion creating subspace, and the corresponding implosion of space upon it. The cavity created by a gunshot in water is a miniature low-energy mimic of the sun's oscillations, an eternal battle of implosion and explosion that we observe through the science of helioseismology. Then there is the mantis shrimp that kills its prey by creating cavities so energetic that they produce light and temperature comparable to the surface of the sun. Here we can see the repeating pattern of energy emitting cavitation in nature. It is not necessary to describe a dense interior in order to propagate energy. My final observation of note is the lightning initiation problem in thunderclouds. The problem is that the measured charge between the two clouds appears to be way too weak to inaugurate a lightning discharge between the two. And after the lightning is inaugurated, how does the lightning propagate for tens of miles through clouds? How do you turn air from being an insulator into a conductor? This puzzle could conceivably be solved if lightning is a spiral of electrons and protons temporarily producing a subspace filament within. This filament becomes a superconductor highway that allows for the unobstructed flow of electrical current. I acknowledge that the concept presented here is a brutish thumbnail outline, perhaps not unlike Aristarchus plopping the sun into the center of the solar system with exceedingly little data to back up the concept. But there are too many repetitions in nature that begs for this hypothesis to be taken under consideration and seriously investigated. With the observations present, it certainly aligns itself to a much greater extent than that of the hydrogen fusion core theory, which scientists slavishly subscribe to with a cultish zeal on par with that of our 2,000-year geocentric dark age. Will humanity have to laboriously trudge down yet another dark path of our own creation? It is presently popular for quantum mechanics scientists to claim that absolute vacuum or subspace is not possible, that the dictates of vacuum mechanics on this largely unknown frontier would have it that subspace cannot exist. But then again, less than 100 years ago, knowledgeable scientists claimed that aircraft could not fly faster than the speed of sound. I do understand the proposal offered here gives birth to a plethora of questions. How does subspace that gives rise to the magnetic bottle deflect all radiation? Is it something in the nature of subspace itself? I cannot answer this. Also, from Earth geology, we have a pretty good idea that the Sun has been around for about 5 billion years. How is it then that the matter that makes up the photosphere shell has not long since exhausted its fuel, causing subspace to collapse with an almighty pop? We are in a time when the Voyager space probes are at the very frontier of our solar system, and we are discovering that this heliospheric boundary where the sun's envelope meets galactic space is much more complex than the bow of a ship ploughing through an ocean. Quite the contrary, we are discovering that there is a complex exchange of magnetic fields, radiation, and particulate matter between the solar envelope and the galactic space surrounding it. We have a pretty good idea that as the sun orbits the galaxy, the shock wave of the sun's magnetic field impacts external space, causing statically charged particles to be captured and ride the sun's magnetic fields into the poles, where they are absorbed, somewhat reminiscent of a feeding mechanism. Could this be the function of what is turning out to be a surprisingly complex outer heliosphere shell? That as the sun orbits about the galaxy, meandering through gas and dust clouds, that it is using gravitation and the magnetic heliosphere to graze and maintain the sun's photosphere? Another thought which I base on laboratory-proven observations is that at the boundary of almost perfect vacuums, virtual particles spring into life. So could it be that for a monster magnetic bottle full of subspace, virtual particles are just child's play in comparison? Rather, that the electrons and protons, or perhaps whole hydrogen atoms, spring forth from the subspace? It just seems so unintuitive, but the observations we already have force me to contemplate it. I'm sure you can think of other questions, or if I'm fortunate, the solutions. Thank you for watching this presentation all the way through. I'm impressed. Goodbye.
His hat on, hip, 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 hooray. The sun has got his hat on and he's coming out today. Now we'll all be happy, hip, 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 hooray. The sun has got his hat on and he's coming out today. So jump into your sun bath, hip, 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 hooray. The sun has got his hat on and he's coming out today. All the little birds are singing, all the little gnats are stinging. All the little bees in twos and threes, buzzing in the sun all day. The sun has got his hat on, hip, 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 hooray! All the little boys excited, all the little girls delighted. What a lot of fun for everyone, sitting in the sun all day.